Hey guys, this is Mrs. Keith, and I want to do notes over segment addition. We need to understand what the segment addition postulate is first. Basically, I'm going to write it out. The parts of a segment will add up to equal the whole segment. So basically, when you do part plus part, it will equal the whole amount. All right, so for example, if we have a segment AC, and we've got B somewhere between A and C. We don't know if it's in the middle, so we can't use the midpoint or any of that. We can't say AB is equal to BC because we don't know if B is a midpoint. What we know is the parts, though, AB plus BC should equal the whole amount AC. So that's what we're going to focus on today. We don't know that the point located between A and C is in the middle, so we won't be able to use the midpoint like we did last class. All right, so let's do an example like number 1. We've got line M. Remember, if you name it like this, you're just putting a lowercase m over on the side. Point E is between D and F, so I'm just going to make point D and point F, and I'm going to put E somewhere between those two. All right, and then I'm going to label it with what they tell me everything equals. So they tell me EF is 50, so I'm going to label this with 50. They tell me DF is 63, so this whole length here is 63, and they want us to find DE. So the equation I'm going to set up, I know the parts, I'm going to write that out. The part plus the part is going to equal the whole. So you've got the part DE plus the part EF. That should equal the whole amount DF, which means DE, we don't know what that is, plus EF, which is 50, should equal 63. Well, if I'm solving for DE right here, to do that I'm going to have to subtract 50 from both sides. And I'll end up getting that DE equals 7. And you probably looked at that and could just easily tell that. That's basically what we're going to do, though, with some expressions with X in them. All right, let me scroll this up. All right, let's make this a little harder. We've got segment JL, and point K is located between J and L. If JK is 7x plus 9, I've already got that on the picture, and KL is 9x plus 9. And JL is 114, so I know that this whole length JL is 114. Well, I can set up an equation. I know because of the segment addition postulate that the part plus the part should equal the whole. So we've got part JK plus part KL should equal the whole amount JL. Now I'm just going to plug in what I know. I know JK is 7x plus 9. I know KL is 9x plus 9, and I know JL is 114. Now I can solve that equation. Remember, if you have x's on the same side, you're just going to combine like terms. So I can combine that 7x and 9x to be 16x. I can combine 9 and 9 to be 18. Now I can solve it. I want to get x on one side, so I'm going to subtract 18 from both sides. And I get 16x equals 96. Then I'm going to divide by 16, and I get that x equals 6. So I have not finished this problem. This didn't ask me for x, it asked me for KL. So remember, KL equals 9x plus 9. I'm going to plug in what I got for x, so 9 times 6 plus 9, that's 54 plus 9, which gives me 63. So I know that KL equals 63. And you can check your work. Go ahead and find out what JK is. I could do 7 times 6 plus 9. I get 42 plus 9, which is 51. 51 and the 63 we just had should combine to be 114. So I know for sure I did that correctly. All right, let's do another one. All right, we've got CA is x plus 1. And we've got AT is 2x plus 3. and we've got that this length CT right here is 4x minus 1. All right, so again, we're going to use the segment addition postulate that says that when you take the parts and you add them together, they equal the whole amount. So my parts are CA plus AT, and they equal CT. All right, they tell me CA is x plus 1. They tell me AT is 2x plus 3. And they tell me CT is 4x minus 1. Now I'm just going to solve it. So combine these x's to simplify things before we start moving things around. So that gives me 3x, and then 1 plus 3 is 4. Now that I have it simplified on the left and the right, I can start moving things. So I'm going to move this 3x over here by subtracting it. That gives me 4 equals x minus 1. Then I'm going to move this 1 over here, so I get x equals 5. Now again, it didn't ask me for x, it asked me to find AT, so I've got to plug that in. 2 times 5 plus 3 gives me 10 plus 3, which is 13. So AT equals 13, and that's my answer. All right, I moved that down a little bit so it erased what I just did, but you can rewind if you need to see it again. All right, on number 4, we've got JK shown below, and we're told that it's 3x inches. Point L is located on JK such that JL is 20, and LK is x squared plus 2. We kind of worded that weird. The more I'm reading it, I think we probably said point K is located on segment JL. I'm sorry. Let's fix that. Point K is located on JL. Sorry about that. I'll fix it on the notes that are blank for you guys. All right, we're going to use the segment addition postulate again, and we're going to say part plus part equals the whole amount. So the parts are JK plus KL equal the whole amount, which is JL. Okay, so plugging in what we know JK is 3x, we know KL is x squared plus 2, and I know that JL is 20. Now remember, anytime that you have an x squared, you have to get everything on the same side in the form, in standard form. So ax squared plus bx plus c equals 0. So it has to be equal to 0 so that you can either factor or do the quadratic formula. So when I do that, I'm going to put the x squared first. The 3x will be next. I'm going to move the 20 over here by subtracting it from that 2, so it becomes minus 18. Now that it's equal to 0, I can factor. So this will factor to be, I know x will go here and here in order to multiply together to get that x squared. I need something to give me negative 18, and then when I combine this and this, it gives me a positive 3. So I'm going to choose a positive 6 and a negative 3. 6 and negative 3 multiply to be negative 18, and when you multiply this 6x, or add the 6x and this negative 3x, they'll combine to be that positive 3x. So your factors are x plus 6, you'll set that equal to 0, and x minus 3 equals 0. And then solving for x, I'll subtract 6, and I get x equals negative 6. Here I will add 3, and I get x equals 3. Now both of those are possible solutions. The only problem is when I plug in this negative 6 right here into the JK segment over here, 3 times negative 6 is a negative 18. And I can't have a negative segment length. That's just not possible. So we're going to exclude this answer choice. And my answer for x is going to be 3. And that's what they're asking me for here. All right, that's it for your notes. Thanks.